Welcome everyone, and I know I'm not there today, so I thought I'd make some videos to kind of review some of the things we talked about the last time that we met. What we started on is we're taking notes for section 8.1. Some of you may have been here for the notes, some of you may not have, so you can at least watch this video and get caught up on some of the things that you're missing. We started on section 8.1 out of secondary 2, and what it has to deal with is what we call similar triangles and dilations. And one thing that's important about this is that we're no longer going to have triangles or quadrilaterals that will end up being the same size. We'll be multiplying them by a scale factor, and when we have a scale factor, what it does is it keeps the same size, but it doesn't keep the same shape. So scale factor will be important. And another thing is the shape of the thing is preserved, the object, the image versus the pre-image, but size and shape is not. And so if you look over here at this little figure here, we've got the original figure is P, Q, and R, and I take a dilation of this by some type of scale factor greater than 1, it's going to blow it up, and it's going to be a little bit bigger. And so the scale factor, let's say if I was thinking about this one, and let's say this side here was actually 2, and the new side here is 4, that scale factor would be 2. 2 times 2 is 4. You take the new image, multiply it by the scale factor, or you take the old image, multiply it by the scale factor, you get the new image. So, that being said, let's say if this was 4, I times it by 3, if I had the scale factor equaled 3, then 3 times 4 would be 12. So those are some of the ideas that you have to remember about this today. Let me erase this. So one thing you may want to note here is to make sure you have this diagram drawn on your paper. So if P and center point C are not the same point, so here's P and center point C are not the same point, then the pre-image P, this is the old one right here, that's the old, and the image P prime, this is the new. They will be given by the scale factor of C prime. So the scale factor between this line C and C prime and the old one divided by C and P. Okay, so it's always the new image and the old image. So sometimes you can compare sides like we did here. 2 times 2 would give me the 4. If this was 4, it was a scale factor of 2. 2 times 4 would be 8. So there's 2 types of dilations you can have. So if a scale factor is greater than 1, like it would be 1.5, 1.25, it would maybe 3, it's called an enlargement. So the new image will be bigger than the old image. Now, if you have a reduction, that's the other type that we can have, then that means the scale factor K is between 1 and 0. So, for instance, if I had one diagram here, let me just make me one here, and I'm going to take this and copy it. And let me move it over here, and let's say that I shrink it. Let's say I shrink it by, let's say, 50%. There we go. Then this is my new one. This would be the old one. Let's say if the old one is 4 and the new one is 2, I take the new one divided by the old one, and my scale factor is 1/2, or you could say it's 0.5. So that's what we're talking about, a reduction. So it's just opposite of what this other one would be. So are we okay with that? All right, I'm going to go ahead and erase this. If you have any questions about this, you certainly can watch this video again. Okay, for a sample problem that we have on the notes is we're supposed to draw the image of ABCD prime by dilating the original image ABCD by a scale factor of 2. So the first thing we want to do is list all our ordered pair, and once we list them all, we're going to multiply them by the scale factor of 2. So let's list them all here. So A is the ordered pair 2 and 4. Make sure that we get these right because we can't make mistakes here. So 2 and 2. And then I have C is at 5 and 3. And so as you do this on your paper, you know, like on your homework or maybe on a quiz or something like that, make sure that you list these points out and it takes all the guesswork away. So D is at 6 and 7. And we're going to multiply all these ordered pair by the scale factor of 2. That's our scale factor. And that will usually be given to you. So from here, 2 times 2 is 4. So A prime should be 4 and 8. It's almost like using the distributive property. B is 4 and 4. C is 2 times 5 is 10. 2 times 3 is 6. So C prime would be 10 and 6. And then D prime, 2 times 6 is 12. 2 times 7 is 14. So now let's go ahead and draw our ordered pair, or draw our new image. So A is 4 and 8, so there's 4 and there's 8. 4 and 8, there's A prime. B is 4 and 4, there's B prime. C prime is 10, there's 5, 10, and 6, there's 5 plus 1, so that has to be C prime. And then finally D is at 12 and 14, so there's 12 and 14. I'm going to have to slide this down a bit. So there's 10, 12, 14, so 12 and 14 would be right there. There's D prime. Now we'll go ahead and use your straight edge, and you will connect these points together. There's B, and then C. So this is the old image right here. And this image right here is the new one. Now, a couple of things to remember. If this length of this side here was 5, 2 times 5, the length of this one would be 10. And it's the same way with the ordered pair. If I wanted to find my scale factor, I would take the new one divided by the old one. It's going to give me my scale factor. Or you could also do this with the ordered pair. I could take 4 divided by 2. That would give me 2, and I would check it with 8 divided by 4 would also give me 2, and that checks it so you can make sure that you have the right scale factor. And another way to check it again, remember you can take your straight edge, and if you've graphed your problem correctly, I lined the origin, the 0, 0 up with the point, and it should go, B and B prime should be on the same line. I can check here with C. I line C up with the origin, it should line up with C prime, and so forth with D. If I line D in the origin up, it should hit D prime up here, and the same way with up 1. Okay, so we have another problem here that we're going to be doing. We're going to take this larger one, we're going to reduce it by 1/2, and so let's go ahead and list our ordered pair. So A is -8 and 7. B is a -4 and looks like 9. C is a -6 and 15. And then D prime is a -14 and 11. And then we're going to be multiplying these all by 1/2, which is the same as division by 2. So let's go ahead and we'll find A prime, B prime, C prime, and D prime. So I'm going to look at these like I'm dividing by 2. So 2 into -8 will be a -4. 2 into 7 would be 3.5. And I've gone through with my calculator and figured some of these already, so I don't have to put them up on the screen. Okay, so the next one will be a -2. 2 divided into a -4 will give me a -2. And then 2 divided into 9, or 1/2 times 9, will give me 4.5. Okay, let's look at C. Would give me a -3 and 7.5. And then D would give me a -7 and 5.5. Okay, so let's go ahead and graph these. A is a -4 and 3.5, so that would be A prime. B is a -2 and 4.5, so that would be B prime. C would be down to a -3 and 7.5, so there's 7 right there. 5 plus 2 is 7, there would be the half. And there's that, so that's C prime. And D prime would be a -7, and then 5.5 would give me right there, so that is D prime. I'm going to go ahead and connect my dots, and then I'm going to go ahead and do the line test to make sure they line up. So I'm going to go ahead and use a black marker on this. So let's take it from the origin. Let's look at my A. If I go from A and I go through A prime, they should line up. Do you see where they line up? If I go to B, do you see where they line up? If I line up with B, it automatically lines up with B prime. If I line up with C, it automatically lines up with C prime. If I line up out here with D, it automatically lines up with D prime. So I know I've done my dilation correct. Okay, so that's finishes the notes, and there we go.